So today we're going to be talking about how to measure angles in another unit called radians. So if you look here on the screen, the definition of a radian is, and the definition's there, but I do want to kind of interpret what that means. The definition of a radian is a central angle of a circle has a measure of 1 radian if it intercepts an arc with the same length as the radius. So what that means essentially is, if you take a look at the picture, that arc there, call it S. If that length is the same as the radius, then that angle that marks out that arc would be considered 1 radian. And if that still doesn't make a bunch of sense, another way to kind of think about it is, if I want to find a measure of an angle in radians, specifically on a circle, then you can think of it as the ratio of the arc length over the radius, shown there. So theta, being the angle, can be considered the arc length divided by the radius, and that would be in radians rather than in degrees. So I just wrote 1 radian there just to kind of show that when those little tick marks mean that the arc there is the exact same length as the radius. Now, that being said, the thing that we really need to understand is how to connect degrees and radians. So today we're going to talk about how to convert between degrees and radians, but before we do that, I do want to give you kind of an idea of what that looks like on the circle. So consider the entire distance around a circle. It's called the circumference, and the way you measure that is 2 pi r. So if I draw a circle here and show 1 revolution, that's 360 degrees, and that's how we've been measuring angles on the unit circle so far. But if we think about our definition of a radian, or a measure in radians, it's the arc length, or the length of the arc divided by the radius. So if I'm talking about the entire circle, then that's really the circumference divided by the radius. And if you take a look real quick, if I did 2 pi over r, or 2 pi r divided by r, 2 pi r is the circumference, and divide that by the radius, the r's would reduce, and what the angle measure would be is 2 pi radians. So what that really means is, if 1 full revolution around the circle is 360 degrees, what that is 2 pi radians. So if you rotate around the circle 1 full time, that would be 2 pi radians. So then what if I did half a circle, or 180 degrees? Well, that would be pi radians, or half of 2 pi radians. So if we take a look at the circle here up at the top, if I work my way around the circle in degrees, I have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 if I go all the way around the circle. But what would that be in radians? Well, 0 is still 0, and pi is 180 degrees. That means halfway between 0 and pi would be 90 degrees, or pi over 2 radians, or 1/2 pi. They're the same thing, which means 270 degrees would be 1.5 pi, which is more commonly written as 3 pi over 2. And there's some other angles along the way that we'll definitely mark out, but for now, just getting those equivalents is going to be huge. So 0 degrees is still 0, and one thing I do want to point out right now is, if we're talking about angles and it doesn't specifically have a degree sign on it, then you treat it as if it's radians. So we really have to be careful with our units moving forward. So just a quick example, if I said cosine of 0 degrees is 1, that would be the point on the unit circle at the angle 0. Cosine is the x value, so it's 1. But what would that be in radians? Well, it'd still be the exact same value. Cosine of 0 radians is still 1, because it's still in the same place on the unit circle. So then what if I asked you for sine of 90? So 90 degrees is the point 0, 1. Sine would be the y coordinate, so that's sine of 90 degrees is 1. But another way to write that would be, an equivalent way to write that would be sine of pi over 2 would be 1, and pi over 2 is the radian equivalent of 90 degrees. So we've kind of talked about it a little bit in terms of in your calculator having degree mode and radian mode, and that's essentially what we're doing when we're finding values of sine and cosine. We have to make sure that our calculator, or that we're dealing with the correct measurement unit, whether it's degrees or radians. So that's really what a radian is. It's the ratio of the arc length divided by the radius, and we're going to start building equivalencies from the degrees we've been talking about all this time to its corresponding radian measure. So the thing we definitely have to learn is how to convert back and forth between degrees and radians. So if I have an angle in degrees and I want to convert to radians, I would multiply my angle by pi over 180 degrees. And the reason why that works is if you think about any sort of conversion, if I want to convert feet to inches, I would multiply by 12 inches over 1 foot, because there's 12 inches in a foot. A similar conversion is happening here because pi radians is equal to 180 degrees. So when I multiply by pi over 180, the unit I'll be left with is radians, and I'll show you that in a second. And then the converse of that, the flip side of that, is if I want to convert from radians to degrees, then I would multiply my angle in radians by the conversion factor of 180 degrees over pi radians. And the unit you'll be left with there is degrees. So let's take a look at an example. So if you look at example 1a, if I want to convert 60 degrees to radians, I would multiply 60 degrees by pi radians over 180 degrees. You don't have to write radians every time. I'm going to at the beginning just so we see how the units kind of work out. So then how do I multiply? Well, the degrees would cancel. So I'd have 60 pi multiplying across the top over 180 in the bottom, and then the unit that you'd be left with, that value, that number, is going to be a radian value. So then all you have to do is reduce 60 and 180, and for the most part, most of your angles in radians will be in terms of pi. So there'll be a pi in the answer a lot of times. So all I would do is reduce this to pi over 3, because 60 and 180 reduce to 1/3. So 60 degrees is pi over 3 radians. And then 11 degrees, I would do the same thing, multiply by the conversion factor of pi over 180 degrees. The degrees would cancel, and I'd be left with 11 pi over 180, and that would be in radians. Now that doesn't quite reduce nicely. I could plug that in my calculator and get a decimal, but for now I'm just going to leave it in terms of pi, and that would be your answer. And then example 2 is going the other way. If I want to convert from degrees to radians, then I would want to multiply my angle in radians, 4 pi over 3, or 4/3 pi, by 180 degrees over pi radians. So the pi's would reduce. So I'd have 4 times 180 in the top, 3 in the bottom, and then the 3 will reduce with the 180, leaving me 60. So I have 4 times 60 degrees in the top, which is an angle of 240 degrees. So take a look there. Essentially, we're just trying to convert from one unit measure to the other. So you have to make sure that your conversion factor makes sense. So if it's in radians, you want radians to be in the denominator, so those units would cancel. And if your angle's in degrees, you want degrees to be in the bottom, so those units will cancel. So 2b, I want to convert 3 pi to degrees. I'd multiply by 180 degrees over pi radians. The pi's would reduce, so I'd have 3 times 180 degrees, which is 540 degrees. And if you located 540 on the unit circle in degrees and located 3 pi, we'll talk about where that would be in a minute, they'd be in the exact same place because those angles are exactly the same. And now C is a little bit different because it just says 2, but like I said, if it doesn't specifically have a degree symbol on it, then it's in radians. So I want to convert 2 radians into degrees. So I'd still multiply by 180 degrees over pi, and that's in radians, and technically 2 is in radians as well. So just kind of squeeze that in there. The radian unit would reduce, so I'd be left with 360 degrees over pi, and that one's not, a really nice angle measure that we kind of recognize. So that one might be a good idea to kind of convert in your calculator, or just plug that in your calculator to give you an idea of what that angle is. So 360 degrees over pi is about 114.591 degrees. So that's converting back and forth. Just make sure that your conversion factor is in the right form. So going from degrees to radians, you want radians in the top, degrees in the bottom. Going from radians to degrees, you want degrees in the top and radians in the bottom. Then if we're talking about finding which quadrant an angle in radians is, we talked a lot about where an angle in degrees puts us around the unit circle, more than one rotation going backwards. But now we want to kind of get an idea of where 2.5 radians is, or 5 pi over 3 radians, or 11 radians, just to have something to work with. And for now, the easiest way is probably to convert to degrees. So if I convert to degrees, that'll kind of give me an idea of where I'm located, which will let me know which quadrant I'm in. So if I want to convert 2.5 radians to degrees, I would multiply by 180 degrees over pi. Radian unit would reduce. So I'd get 450 degrees over pi, or 450 over pi degrees, which that we don't really know what that means. That's not a number we can kind of do in our head. 450 divided by 3.1415 is hard to kind of calculate. So if I put that in my calculator, that's approximately 143.239 degrees, which would put you in quadrant 2. So as we get more comfortable and get a little further in this, we wouldn't necessarily have to convert every time to know where we are, but for now, it's probably a good idea to do so. So if I convert 5 pi over 3 radians to degrees, I would multiply by 180 degrees over pi radians. My radians unit would cancel or reduce, and my pi's would reduce in this case as well. So I'd get 5 times 180 in the top, 3 in the bottom. So I would reduce 3 in 180, and I'd get 60. So 5 times 60 is 300 degrees, and 300 degrees puts you in quadrant 4. And then for 11 radians, I would do the same thing. I want to convert that to degrees, just so I have an idea of where that is. So multiply by 180 degrees over pi radians, and that would give me 1980 over pi degrees. And that gives me, in my calculator, because again, just to get an idea of what that is, it gives me 630.253 degrees. Now, the tricky part about this one is we should hopefully know that it's more than one revolution around the circle, but that doesn't quite tell me exactly where I am past one revolution. So what I would do is take my angle measure and subtract 360. That'll basically tell me how far past one revolution I am. And I get 270.253 degrees. And if you remember where 270 is actually exactly on the line between quadrant 3 and quadrant 4, which means if I go slightly past 270 to 270.253, that would actually put me in quadrant 4 just ever so slightly. So if you ever come up with a conversion and you get an angle that's more than one revolution, it might be a good idea to kind of figure out how far past one revolution it is, so that you kind of get an idea of where that angle would be located on the unit circle. Now for example 4, we essentially want to figure out how many rotations a certain number of a certain radian measure is. So kind of talked about what 2 pi is, so you might be able to answer that one without doing anything, and you might say, well, 2 pi is exactly one revolution, and you'd be right. But if I drew a picture, 2 pi would be one revolution around the circle, because that would be 0. Starting at 0 going around is either 360 degrees or 2 pi. So that would be exactly one rotation or revolution around the circle. Now 7 pi is a little bit trickier. You might be able to do this without drawing a picture, but I'm going to. So I know 0 to pi is shown there so far. And then if I go halfway around again back to where I started, that's 2 pi. And then go halfway again, that would be 3 pi. I'm just counting by in multiples of pi. And then that would be 4 pi, or 2 full revolutions. That would be 5 pi and 6 pi, which would be 3 full revolutions. And then that right there would be 7 pi. So 7 pi is 3.5 rotations around the circle. And then this one, 3 over 3, that should be 3 over 2. There's a typo there, so let's make it 3 over 2 and figure out where that is on the circle. So I just put 0 in pi. So that right there is pi. And then thinking about fractions, or the way we're going to write this, is the one between 0 and pi is pi over 2. So then going to 3 pi over 2 would be the same distance past pi as pi over 2, which is 1.5 pi, but it's always going to be written as an improper fraction. It's a little bit easier to deal with. So 3 pi over 2 puts me right there on the y-axis, which is 3/4 of a rotation around the circle. And then the last thing we need to talk about is a formula, and we'll talk about the arc length formula in degrees first, and then we'll later talk about arc length in radians. And now what arc length is just the length of a certain part of the circle. So it's a certain arc or portion of the circle's circumference, and that's what the length is. So if I want to calculate arc length in degrees, because it's a slightly different formula, here's what it would be. So if I want to take an angle theta and I want to find the length of that arc, I kind of colored it in red there. I want to figure out how long that piece of the circle is. The way I would find that is, call it S, is the accepted variable for arc length. The formula would be theta, which is the angle, divided by 360, times 2 pi r. And if you know me at all, like I'm not a huge memorize formulas advocate, but this is one you got to know. But what I want to do is kind of give you a glimpse into where this comes from. So if you think about what the theta over 360 represents. So theta is the angle of the circle in degrees, and 360 is the whole circle. That means theta over 60 is really just a fraction of the whole circle. So it's just a ratio. So whatever your angle is that marks out your arc, divided by the total circle. And then I'm going to take that fraction and I'm going to multiply it by 2 pi r. And what 2 pi r is the total circumference or the total arc of the circle. So essentially when I'm calculating arc length, I'm taking how much of the circle my angle marks out and multiplying it by the length of the whole circle. That's what circumference is. It's really perimeter of a circle. So if you look at example 5, if I want to figure out the arc length, what I have is a circle. I just drew, a circle. There's the radius is 7 inches. It's given. And the angle is 60 degrees. And what we're trying to find is the length of the arc that's marked out by that 60-degree angle. Now, because the radius is 7, that length is going to be different than it would be on a circle that was a different radius. And we'll talk about that a little bit later. But the idea is I need to make the arc length specific to this circle's information. So what I like to do is think about this formula as kind of what we know and what we don't know. So I know it's going to be some angle over 360 times 2 pi times r. And r and the angle are what's specific to this problem. So I wrote them as if they were blank there. You didn't have to necessarily do that step, but I like to just kind of show you where this information is coming from. So to find this arc length, I would take my angle, which is 60 degrees, write that over 360, and then take my radius, which is 7 inches, and put that in for the radius of the circle. So I'm taking 60 over 360, which is can be reduced to 1/6, and then I'm multiplying it by the total circumference of the circle, and the total circumference is 14 pi. So I want to just do a little bit of simplification. That would be 14 pi over 6. And then in terms of units, it's not degrees, it's not radians. We're talking about the length of a part of the circle. So what that's going to be is in inches. So what I would do is just reduce that and call that 7 pi over 3 inches. And that is an exact answer. That's totally acceptable. But the problem with that answer is it doesn't really give us an idea of how long that is without us having to do further math, right? You have to do 7 times 3.1415, whatever, divided by 3. In problems like this, if we're talking about length, it might be a good idea to write it as a decimal if you have access to a calculator. Either way, the answer is the same, and what you would get if you put that in your calculator would be 7.330 inches. So that would be the length of that arc measured out by that 60-degree angle. So that's kind of an intro to radians, an intro to some of the things we use them for, and conversions back and forth between degrees and radians. Practice these things on your homework tonight, and bring some questions for me tomorrow, and hopefully I can clarify anything that you didn't quite understand the first time. Thanks, and I will see you tomorrow.